Hello everyone, welcome to the channel Data Science with Harshit. So I have been working on a lot of machine learning and data science projects lately, and one thing that I can share from my experience is that every time you pick up a project, you have to cross this bog of data cleaning and data wrangling, which is the most tedious task for the majority of analysts and scientists working in the field. So basically, before you reach the sexiest part of your project, which is machine learning or model engineering, where you are tuning hyperparameters, looking at those metrics and figuring out which configuration basically works best for your model. So in order to make my life easier as an analyst, before I reach to that part, basically I have looked at a few hacks and libraries that I keep using now in most of my projects. So in this particular video, I'm going to be sharing a few of my findings and configurations that basically I use in order to speed up my analysis, in order to speed up my task in all the data science projects that I do. So I intend to cover this in two sections. The first one is some of the Jupyter hacks, the configuration that I use while working on my Jupyter notebooks, and the second the later part of the video we would be looking at a few interesting libraries that are really interesting to work with. So you should definitely watch that out. Alright, so without any further ado, let's dive right in. Since you spend a lot of your time with your Jupyter notebooks, let's try to give your notebook a new theme so that you stay focused and you enjoy working with your notebooks. So I have this new package called Jupyter Themes, which is developed. It's an open source project developed by Kyle Donovan, and yeah, it's an amazing project. All you need to do is install this package, pip install Jupyter Themes, and the documentation basically walks you through what the steps are. So they have these various command line options that you can use in order to set the theme, font size, color, cursor width, and a bunch of other factors that they have provided over here. So I have figured out a theme and all the other sizes and configurations that I can share with you. So I have this theme called Monokai, and I am using it with the font this Fira. Font size is 12, minus NF is notebook font. Notebook font is PT Sans, and then notebook font size is 12. Minus N stands for that I want to make the notebook name and title logo visible. Then I have cursor width 2, cursor color is red, and then cell width is 90%. Minus T is for taskbar. I want to make my taskbar visible as well. So hit it. So I have already installed the Jupyter theme, and yeah, now if I am going to restart my Jupyter notebook server again, let's start the notebook server. Let's see what this looks like now. All right. So you see, this is how our notebook looks like now. So if I go into this project, I have this new project called Pro Tips and Tricks, and this is basically what my Jupyter notebook would actually look like. So I have my taskbar visible. It's because of the minus T option that I added, and I have all the other things visible. So it's going to take a few seconds. Yeah, so you see the title, file, edit, all the other options. So this is the notebook that you are going to be working with. So this looks a lot more amazing. It kind of gives you that sublime text feeling, and I personally enjoy working in this particular notebook. Now, if you want to go back to the original theme, all you need to do is hit JT minus R and hit enter. So this will basically take you back to the original theme. So commenting out code is one of the most important and useful practice for any developer or analyst. So before you actually go ahead and finalize your analysis, you should never delete your code blocks. You should always comment them out so that you can reuse a bunch of things that you would have done in those blocks. So there's a very quick keyboard shortcut that you didn't know about, and this is command plus slash. So if you hit command slash on your keyboard, so this will simply comment out your line of code. Or if you select a few lines, let's say 3 lines are selected, and I hit command slash on my keyboard, all of those 3 lines would be commented out. So this is basically a very interesting and very quick way of commenting out code. So we all know how grateful we are for Control Z or Command Z that restores the content of a particular cell that we are working in. But sometimes it would have happened that you would have deleted the cell by mistake and you don't have anything to go back. So let's say you followed the above rule of commenting out the code but deleted the entire cell by mistake and you want to restore it. So we have a shortcut for that. All you need to do is press escape plus Z on your keyboard. You will have your cell restored. So let's say I delete this cell right over here. Now, how should I get this back? So if I hit escape plus Z on my keyboard, or you can do edit and go to undo deleted cell. So next up we have is magic commands. So as the name suggests, these commands basically have some supernatural powers, and that powers basically save you from smashing your head into the wall. So jokes aside, so if we first have this percentage run magic command. Basically what it does is whenever you have to run a script, let's say you have a Python script and you want to run it in your environment, in your workspace, in your notebook. So what you do is you simply mention the percentage run and then provide the name of your Python script. So I have this in my folder, I have this example.py. So let me just show you what it contains. So I have a few very simple functions, sum, product, divide, subtract, and I have a and b, these variables, which are both equal to 5. Now if I go back to my Jupyter notebook, now if I run this cell, I ran this cell. Now there was a defined as 5. So if I look at a, so you see the output of the cell gave me 5, whereas it is not defined anywhere in this notebook so far. And if I, let's say, do call the divide function, which is not defined in this notebook, but we could invoke this function because it's already run in the example.py file. It's already there in the example.py. So all I need to do is mention a comma b. A comma b here are not defined in the notebook, but it was there in the example.py, and we ran the script. So we would have the result as 1.0, 5 divided by 5, 1.0. Now, the next file is the next command is percentage load example.py. So what it does is, let me just quickly. So next command that we have is the load command. So in order to, so if you don't want to, let's say, run the script, you simply want to load the script so that every variable and function becomes available for you to use. So all you do is you run percentage load and then the name of the script. Your script has been loaded into your workspace, and then you can use all these functions and variables that are defined in that particular script. Next, let's say you want to write a file. Now you want to write the content of a cell into a particular notebook. So what you do is you simply mention the percentage write file magic command, and then mention the name of the file that you want to write it to. So you see that we do not have any new.py over here. So what we do is we simply write this write file magic command and the name of the file. When I run this, this would give me a writing new.py, and when we go back here, so you'll see that we have a new.py file created for us, and if we open this up, you'll see that the code that was in the cell is now present here in the notebook. So next up we have is percentage time. Now this is a very useful magic command which returns the CPU execution time that it took to run the cell. So you can use it like this. So you can simply mention the percentage time before the code snippet that you are running, that you're basically wanting to test. So you run the cell and it'll basically give you the CPU times. That is 3 microsecond, and all the other total is basically 3 microsecond. Now wall time is 9 microsecond, and basically this is the operation result. I'm printing all the elements of the list. So it's again a very useful function when you are actually looking at how much processing or execution time it would take for your script or your code to run on the machine. The next command is basically very simple. So sometimes what happens is you don't want to run a particular cell. So what you do is you simply mention percentage script false. So let's say when you open a new notebook and you want to run all the cells, but there are a few cells, let's say some model training cells, which take a lot of time, and you don't want to run those cells. You would just simply want to capture a few of the initial variables, that's it. So you want to skip a few cells. So how do you do that? You have this magic command called percentage script, and you mention false ahead of it, which tells Jupyter that we don't want to run this cell. So if I run this, it will simply just give me a call processor error, and we would simply move forward. Now, next up, we have Latex. So if you're someone who has to write a lot of mathematical notations, so I was basically creating a lot of my mathematical series, practical reasons for mathematics. You should check out that video as well. So I have this percentage Latex magic command which lets you write latex into your Jupyter notebook. So there's a special syntax that how you write your latex. So I will add the latex cheat sheet in the description below, so that you can basically look at how to write a particular kind of mathematical notation. All you need to do is mention this percentage latex on top of your mathematical expression that you are about to write. So I am here writing a differential equation. So this is a differential equation. So this is basically just the syntax. So when we run this, so you see that this here, the syntax here has been converted into a mathematical expression, which is du by dt and d square u by basically double differentiation of u with respect to x. Now next is percentage debug. So it's an interactive debugger to which lets you correct the errors or look at the errors on the fly. So let's say I have this simple code snippet, a list a, and then I'm calculating the length of the list and capturing it in a underscore len variable, and then I have b equals 95. So I'm storing my result, which is I'm storing this expression's output b divided by a len into this variable result. So when I run this, now the length of a is 0, so this would give me a divide by 0. So when I add percentage debug in the next line, you see that I have got an error. So this is just a simple example that I'm walking you through. So I get an interactive debugger right over here. So I can simply check what the value of the variables were in the previous code snippet. So you see, I have a underscore len as 0, which basically tells me why that particular statement gave me an error. So this is how you can basically check for whatever value was coming into a particular expression because of which you would have got that error. So this is a great interactive debugger to check your errors on the fly. And in order to quit this interactive debugger, all you need to do is press Q on the keyboard and hit enter. So there you will come out of the interactive debugger. And since these are a lot of magic commands, so all you can do in order to learn about what all you can use is you can use this percentage ls magic. This will basically list all the magic commands that are available for you to use. and you can then play around with any of them, Google them and what they do, and you can use them in your projects. So next up we have is some useful libraries, and first off we have is Dabble. Now this library is basically a data analysis baseline library inspired by sklearn that tries to democratize machine learning for beginners, and also takes off all the boilerplate code for all the common tasks. This is an interesting project by Andres Muller, who is also a Python geek and scikit-learn developer. So he's done a pretty good job at developing this. Now, the library contains tools that make it easy for us to clean the data, inspect the data, and also create some baseline model. Now, I have used a simple, very common Titanic dataset over here. I have read the file into a data frame. Then I am calling this clean function from the library, passing it the data frame that I've read. And when I run this, it gives me all the detected feature types. How many are floats, how many integers, how many are objects, continuous, dirty floats, and all such feature types that are there available in your dataset. Now, next thing I do is I call the detect types function and pass in my cleaned data frame. So what it does is it gives me a good report where I examine all of my features as per the feature type that it comes under. So let's say I have survived column, which is not continuous, not dirty float, not a low card integer, but it is a categorical column. So for P class, so basically what all columns are continuous, what all columns are dirty floats, what all columns are low card integers. So I'll get all of the information. So let's say if age is continuous, so in the continuous column, I would have age marked as true. Would have in the categorical column, I would have survived column marked as true. Now, next, what I do is I call the plot function and I mention the target variable that there is. So I have mentioned the survived column, which is the target variable in the Titanic dataset, which tells you whether a person has survived or not. So the target, basically when you run it, so it gives you that target looks like a classification problem. It's survived as our categorical column. It gives you a linear discriminant analysis training set score as well, which is 0.504. It gives you a target distribution, how many have not survived and how many have survived. And then I get a set of continuous features pair plots as well. So age, SP, and then fair. And then I get to look at a few discriminating PCA directions and a bunch of other graphs as well. Now, after that, what I did was I actually, called a simple classifier with a random state 0, and I trained it. I passed my data set, which is the clean data set, and I have passed the target column that I want to check it out for and the predict the results for. So it runs a dummy classifier, runs a decision tree classifier, and tells you what sort of configuration and hyperparameters that it has chosen to run. And out of all these models, it basically chooses gives you the best model. So this is like the best baseline model there is. So I have got this decision tree classifier, which is running in class weight balanced, and it has a max depth of 1. A score accuracy score is 0.801, precision is 0.619, ROC is 0.790, recall macro and F1 macro. So that's like a pretty amazing analysis that you have done with just a few lines of code on one data set. So Dabble basically enables you to remove all that boilerplate code and get started working and building stuff with the baseline model that you have. So next up we have is the Emoji Library. And now, while I was working with textual dataset, I always come across a few emojis that are basically present in my textual data set. So what I do is I want to extract those emojis as well in order to do sentiment analysis, which is again another NLP problem. So whenever you're working with those sort of NLP problems where your textual data contains emojis, so what you do is you have this emote package. So I have installed this emote package, imported the package in my notebook. Now what I do is I have created this sentence which contains two emojis. One is of a sun and one is of a fish. So it's a sunny day and let's go fishing. So what I do is I have invoked this emoji function on my sentence, and I pass the sentence to this function and it gives me this dictionary which I can see. So I have value marked as sun and fish, which are the characters, and then mean is sun and fish, which is within columns, and location is this. So emojis, as you all know, are basically a way of representing human facial expressions or different other objects in the world. So this is again very interesting package to extract emojis out of text. So dealing with missing values is another task, another very common task that you do while exploring your data set. And it's always important to understand the missing values in your data set, what sort of pattern and what kind of values are these, in order to choose one particular imputing method. So I have this Missingno library which allows us to visualize those missing values. So first off, what I do is I install the package and I import it into my workspace. Then I'm using the same Titanic dataset over here. So first off, I am trying to find out what are the null values, and I'm summing all the null values in each of the columns. So I see that age has 30 null values, and then cabin has 125 null values, and embarked column also has one null value. So in order to visualize this better, so all I can do is I have imported this Missingno library as mi. So when I invoke the bar function over here and pass my data frame to it with a figure size, so you can see it gives me a bar plot. So you can see that it gives you a bar plot which tells you which all columns contain those missing values. So you can see that we have 156 values overall, but a few of the columns like age, cabin and embarked have a few missing values. And again, if you want to plot a matrix, you have a matrix function which also helps you visualize those missing values in each of those columns. So you can see those white bars over here which tells you that which is where there's a missing value in each of those columns. So cabin has a lot of missing values, as we can see, and embarked has one missing value right over here. So next up we have is Faker, which is used to create fake data of different categories. Now, I don't know how many of you would have heard of Lipsum text. So just like we use Lipsum text for web development and UI UX as a placeholder for the content that would go on the website. So we have Faker that creates fake data. Now, what I've done is I've installed this package. Then I've imported the Faker class from the Faker module, created an instance over here, and then I am invoking the name function that will give me a dummy random name from a fake name from this name function. So you can see Alejandro Richardson, this is a fake name. Then I've created a fake text, so this gives me a fake text. Then you can create different sort of function. You can create URLs, profiles, anything you want, latitude, longitude, different categories that you can create. You should definitely check out the documentation of Faker. I have added the link in the description. And let's say you want to create tens or hundreds or thousands of values. You can do that simply by adding a for loop. I wanted to create 10 addresses, 10 fake addresses. So this is how I do it: for underscore in range 10, and then I call the address function of my instance, and it gives me these 10 fake addresses. Last but not the least, I have this package called Numerizer, which is used to convert your text numerics into integers and floats. So while I was working on a local bank dataset, they had this separate file which only contained the amount in text numerics. So I had to convert those numerics into integers or floats so that I could process them using our machine learning model. So I have this numerizer library, and what I've done here is I've imported the numerize class from the numerizer, this function from the numerizer module. And what you need to do is simply pass the text that you want to convert. So just like I have passed 42 to this function, and it gives me this value. I have added 21,473 and it has created this for me. So 21 for 473. Again, a very interesting package when you're working with text numerics, NLP data sets. So this comes in very handy in order to pre-process those textual data sets. Now, with that, this is not the end. I have many more libraries. I will keep covering them from time to time, as in what sort of setup that I'm using and other hacks and libraries that keep coming up in the data science space. So I hope you found all of these libraries and hacks interesting. Now I leave it up to your imagination what you want to build with these, and I would say that if you build something interesting, please share your link in the comments down below so that I can look at them, and if I find any of the submissions interesting, I will shout out your name in my next video. So I have added the link to the repository in the comments below, so you can look at that, and in the description, sorry. And yeah, if you found this video useful, please give it a thumbs up, subscribe to the channel, share it, and yep, until my next video, keep learning data science with Harshit.